Good morning, good afternoon, good evening. Hello, everyone. Welcome in the Learn Grasshopper in Tekla webinar series. So it's number 5th webinar. We had some previously, we have Q&A session, we have some webinars, we have interesting experts. And today I have also our expert, Andreas. Hello, Andreas. Can you hear me?
Thank you. Yeah, I hear.
Andras is also the student of Learn Grasshopper platform. So you went through Grasshopper fundamentals, you went through Python training, C# and Tekla training.
Yes, of course.
Yeah, so we have really a student who went through.
I passed all of this.
Yeah, so he got certificates from all of the training. Vanessa is with us. Hello, Vanessa. Nice to see you. Nice to see you. We will start shortly. It's already 9 p.m. Central European time. Just let us know if you can hear us, Vanessa. Previously, we had some issues with the sound, so I hope everything is loud and clear. Just let us know if you can hear us. Let me see. I will check if everything works. We have already some people here. I will start. I will briefly just show what is happening on the Grasshopper in Tekla training. So at December 2024, I added a new lesson. It's called Grasshopper Component. So there you can find new lessons about how to install a Grasshopper component, how to use all the inputs, how to use template, and I added some case studies. As always, for every single modules, we have case studies. And in January, we have updated with new lessons and with new case studies. And I will show you what have we added. So I will see the first one is a case study about beams. I think this is a really interesting one. Simple, but I think it can be interesting for many of you. We have some walls around the building, and the task for you, it will be to add the spiro pipes, these blue columns, blue beams, and what is really interesting here that we would like to also avoid columns. So we would like to also create a kind of outer layer for columns. So we are going to avoid to clash with columns in this one. So I think will be interesting to do it. And here is a pro tip that we can extract the columns. The columns here are given as BROPs. And as you probably already know, if we have modeled them in Tekla, and we would like to take them as a BROPs or meshes to Rhine and Grasshopper, so they will be not the perfect circles. They will be polylines. So here is a pro tip that we can explode this BROP, and we are getting all the points, and we can create a new circle. So it will be a great fit. So we can rebuild it, and you can get perfect circle. So this is the one of the case studies that is already waiting for you. And the second one, some of the students asked me to add more case studies for reinforcement, and I added one more. It's actually from the real project. It's for portal reinforcement for tunnels. And here the aim is to model all the longitudinal and cross reinforcement for the this part, like the beginning part. So we would like to have this reinforcement, as you can see, longitudinal one as in the blue, in the constant radius, and as the red in this one, which is going to be a little bit wider. And actually, we will also have a question what is the length in the meter of the constant part of the profile inside the rock. So inside the rock, the profile is the blue one. Round up to the nearest integer. So good luck with all the case studies. I'm trying to update the training every single month. If you will have any interesting case studies that you would like to add to the training, so please contact me. I'm really open to add new stuff and record new videos. So just contact me directly through email or Discord, and I will add new materials. So that was it from the last updates of the training. Today, Andreas from Hungary is my guest. So let's, if you can, Andreas, if you can share your screen so we can go to the presentation. We have already 15 people live, so you can already share your amazing project. As I already said, Andreas is the GTT student, so he went through all the lessons and now he can show off his work because he, in addition to Grasshopper, he's also using Python and C#, and he was also going to share some work. So Andreas, we can see your screen. The stage is yours.
Okay, Chris, let's start. Hello and welcome, everyone. My name is Andras, and I'm from Hungary. Today, I would like to share 5 interesting projects where I use the connection between Grasshopper and Tekla. This is my story of Grasshopper and Tekla. I have been working as a structure engineer since 2012, and I am currently with the Arches Group. Over the years, I have participated in several major projects, including the transformation of one of Hungary's iconic buildings, the Citadel. During my career, I have primarily worked with steel structures, as well as precast and cast-in-place concrete structures. With these experiences, I have the opportunity to participate in general design, discipline design, and manufacturing design with the BEAM methodology. At the end of 2021 or the beginning of 2022, I came across Chris materials, blog, YouTube videos, webinars, which gave me an extra push to dive deeper into this method and boost my skills. And of course, I am a student of Learn Grasshopper courses. Everyone is familiar with this picture. It was not part of my workflow in the beginning, but nowadays the Rhino and the Grasshopper duo has become integral part of my design work. I used it for structure analysis, joint calculations, and data management. And additionally, I have improved my skills in the parametric environment with API, Python, and C# and AI. But now we are talking about Grasshopper and Tekla connection. Before we start the main part, yes, I wrote a quote of Imre Madac. I think this quote showing the picture might be fit into my presentation, because while our codes are working in background, we can take a rest or perhaps other tasks.
Yeah, this is. I really like that you added the task that we can do another thing, because maybe rest is not the not the proper one, because we have to do our job and we have to work, but we can focus on the different tasks and maybe focus more on the quality. Maybe we can do more fun work.
Yeah, I agree with you. Let's see what the presentation will be about. 5 projects will be presented, and each showcasing a different aspect. In most cases, I use Python, and if I can get the code to work with Python, I create C# code. In most cases, I create Grasshopper scripts that can be reused from project to project with small modification. My goal is to increase the efficiency of my structure design workflows using Rhino and Grasshopper Duo. As I mentioned before, my design processes have changed. Shifting to Rhino and Grasshopper environment, I have started managing files and folders using Grasshopper. The following images showcase these processes, which can also be applied using with Tekla. An example of such as processes delete files. Let's take a look at these processes. Checking the connection with Tekla, or read model path and subfolders, read attributes from firm and model folders, create folder name, create subfolders, read files from folder, move or copy, find files, add a new name, and delete the files or folders. This was necessary so that I wouldn't need to switch the other program on the screen, like Total Commander. And it is easier for me to manage the files, plot files, list, other exported files from the Tekla model. And
I would like to add that I really like this attitude, and all students supposed to see that Grasshopper is not just for Tekla and for just modeling, but it can be also used for the task, as you mentioned, like creating folder, subfolders, and whole list, especially when you are starting new project and you would like to have the same folder structure. So you can reuse the Grasshopper, and in this case, you wrote a Python, right? Python script.
Yeah. Most of cases I use Python. Yeah.
Good. And have you also tried to use Cloud or ChatGPT to help you with creating Python scripts?
ChatGPT and or Cloudy or Microsoft Artificial Agency, they help me, but I use Rhino syntax and Tekla syntax on the API website. Yeah, for creating the script.
Yeah, I really like. Yeah, sorry.
Yeah, because sometimes I modify the AI script because it's wrong.
Yeah, it's really still for Tekla API or Rhino or Grasshopper, it's not working properly because it still has not that much data. And coming back to this slide, again, I will show that this is really cool example to show that Grasshopper can be really versatile and can be used in different ways. Okay, let's go to next slide.
Yeah, and do not forget about plugins into input. So I use read attributes from firm and model folder. Yeah. For example, when we create a drawing or create a part like beam, yeah, we put input data like a phase or other setting from the model. Yeah, let's move on. In the GTT training, we learn how to use Tekla, LiveLink, and Drawing Link. I also use full of range of the plugin for modeling, checking, create drawing, quantity takeoff. Yeah. However, there are cases when an API-based solution can be used to solve repetitive tasks, such as creating phase or creating views or modifying views. Yeah. In this image, we can see the workflow of phases. Yeah, we can do read phase from Tekla or create new phases or modify phases like a name or comment or other attributes, or we can delete it. The next one, this is a view workflow. Yeah, we can do create, open, closed, delete or modify view properties. And the last one, we can say the modification of the grids. All codes are in Python. Yeah.
And can you come back to the first one about the phase?
Yeah.
This one, Andreas he said that he's going to share with students, with the Grasshopper and Tekla training students. So everyone, maybe tomorrow or day after tomorrow, I will send it with the Andreas presentation, because I think this example is really cool. How you can also, if you start your project over and over again, and you would like to have the same setup of phases, so you don't have to type it manually one by one. You can just create and copy from one project to another. So I really like this one, and you can also modify all the phases and delete with this one which are not used. Is it also Python scripting here, or is it just vanilla Grasshopper Tekla Lightning components?
I created in Python.
Okay. So everyone can just check this out, and we are going to include it in the email. Okay, let's move on.
Okay. The first project was wall, concrete wall. In this project, I used the Grasshopper and Tekla LiveLink connection for the first time to model rebars. The geometry of the bridge wall was complex, both in plane and cross section. Unfortunately, the Tekla bridge creator did not help. So due to its complicated shape, there was a need a solution, and this solution was provided by Grasshopper, as doing it manually would have been difficult and time consuming.
Yeah, it's really, the geometry of this wall is really complicated, and yeah, like especially dividing the length of every single rebar, it will be really hard, and especially that you can just make a script for one side and can reuse for the another side the same script, right?
Yeah. In the script there is a mirror nodes. Yeah.
Mm-hmm.
Yeah. 90% of the rebar was modeled using this code. The rebars system was quite special. The stirrups, outer, middle, inner mesh, ball ends, splices, and other rebars could also be added with the code. In Rhino, the geometry appeared without hooks, but of course, I managed the hooks with Tekla plugin. And then in the Tekla model, stirrups shape were already correct. In this image, we can see the full of rebars. Next, I share a short video that how the rebars are added to the Tekla model. First time I met the attributes, general attributes, and UDA. I try to handle as many attributes settings as possible with the code, such as filling in the fields like name, class, rebar numbering, comment. Yeah.
So how many percent of reinforcement were created through Grasshopper and how many manually?
90% of rebar was modeled
through Grasshopper.
Yeah.
Great, nice result.
Yeah. The next project, we designed a custom place building. My task was to calculate and model the punching shear and prepare their plans. In numbers, 3,000 punching rails were included in the model, and 7 plans were attached to the project documentation. I reviewed previous similar designs and concluded that the process could automated. If I were to perform this task manually, I would place the joint in the model one by one, and then count the quantities manually and create the views for each level on the plans. I can say that this is so slow process. So let's take a look at how I solved this. I calculated the joints and then create an Excel file to summarize the results. The modeling of the punching shear was done using the Tekla component named Peiko. The Excel file contains the data for the Peiko component. You can see this. You can see upper of the line of the table with the green field and additional attributes for the quantity takeoff, such as product code and name, class, etc. With the blue field. Yeah. The image shows the complete script. With this script, I can model punching shear, for example, for the circular column or rectangular or ball end. And the script enables the determination of the punching shear layout. And based on the result of calculation, 1 row, 2 row, or 3 rows of punching rails can be modeled. And the next short video, I demonstrate the placement of of the first and the second and the third row of punching shear in Tekla model. And then I check some attributes of the punching shear.
I really like your script. It's really clean. So with all the colors and all the structure, you are really good in creating good scripts. Are you alone at your company who knows Grasshopper, or do you know some colleagues from your company who also know Grasshopper or Python?
Yes, I have some colleagues who design with Grasshopper, but I learned from you and your courses. Yeah.
Because the really scripts are really well made. So good work for you, Andreas.
Yeah, thanks, Tristan. Thanks. Let's move on.
Yes.
Yeah. After the modeling, the next step was quantity takeoff, creating list and plan annotations. I exported the quantities to Excel. Although it is possible to create this Excel file using Tekla template editor, but I think setting that up would have taken longer. Therefore, it is simpler to write a code and use a Grasshopper. The first part of the script with a blue rectangle so is responsible for extracting information from the Tekla, such as quantities and punching shear types. The second part with a green rectangle creates the Excel file, generates the worksheets, and fills every cells in Excel with the information about the rails. In next two images, you can see the quantities placed on the drawing views. These quantity annotations were added as a text, and if any changes in quantity, they are updated using a script. So there is no need for manual modification. On the key plan, I placed the summary of the quantities for the detail, while on the detail view, the quantities specific to that detail are displayed. And the next video, we can see automated drawing creation.
Before, can you just come back?
Yeah.
About the bill of quantity, we have one question. Hello, Leonardo. Leonardo is with us, and Leonardo asked about it. If you also try to create list reports of parts through Grasshopper into bill of quantity, or how you actually made it? Have you used Grasshopper, or have you used for reports Tekla native options?
Okay. This file is created by me, created by Grasshopper.
Okay.
This file has no any Tekla reports or RPT file or TPL file. Yeah, I using Excel plus Food Rhino plugin to create Excel, but I have lots of developing. For example, I use Python or C#, and I want to create Excel without any plugin. Just Python or C#.
Thank you.
Yeah.
Thank you for your answer. Yeah, let's continue to the video with drawings. Yeah, let's continue the video with drawings.
Okay. Yeah. Yeah, so in the video, I show you automated drawing creation using script. I generate and place views, detail marks, and quantity takeoffs on the plane. I show you the number of the detail. And every detail got quantity as a text.
Mm-hmm. So is under every detail is a small table with all the quantities that are shown in this detail, right?
Yeah.
And everything was created through Grasshopper Tekla drawing link.
Yeah. Yes.
Ah, perfect. This looks really amazing. I love this, like connecting bill of quantities together with drawings and everything automized. It's amazing.
If we have any changes around the detail, yeah, I have a check script for the quantities, and if I find any error or failure, yeah, I put the new number in the text object.
Great. Awesome.
Okay. Can we move on?
Yes, sure.
Okay. Yeah. The third project was the residential building. The building is also a monolithic concrete structure. During the project, I had several tasks, among which I would highlight the verification of model data and the preparation of the drawings. I performed the data verification visually using colors, while the drawing sheet generation was done with Excel. For the two questions, I will answer on the next slides. Yeah. If you want to display something in a different color in Tekla, we need to create a custom view representation. For this, various settings must be manually generated in Tekla, such as view filter. With Grasshopper, this process can be done more easily, even by using this code as shown in the image. I have to say, I love these three nodes, like color display, text display, point display. I can use them to create checking, picture, diagrams, and put any annotation in Tekla model. Yeah.
I have to admit that I'm also a huge fan of this one, and they really are game-changing when it comes to showing, checking quality of model, or checking some errors, or checking quantities, and just displaying some text, some points, just points for make it some corrections or more detailed work or changing color. It's really amazing. So let's go to examples, because examples that you prepared, Andreas, they're really clearly show how the display color can be used.
Yeah. So let's take a look at a few examples. The first image, I checked the naming of the beams. The next one, I check the pull phase of the building. Next, I check rebar quantities of the slabs. Green is okay, red is not okay. And the last picture, we can see I check the detail type, detail number, and their rebar positions. The creation of the general arrangement drawing and filling in the drawing attributes is often done manually. And with this image, I would like to illustrate that if we predefine the drawing attributes in Excel, and then we can read them using Grasshopper plugins or Python code or C# code. Plugin, for example, Lunchbox, and then generate the drawings with drawing link, so that the GA attributes will be filled in. The image shows details. The symbols for these details needed to be placed on all floor plans, as shown here. And a similar approach was required for the section mark symbol as well. With the drawing link, we can add dimensions or insert sections view, or add level marks. Let's watch a short video about drawing creation.
I really like how fast they are becoming.
Yeah, and if you have 3 or 4 but if you have lots of plans, yeah, it's plans created just a moment.
And especially that you can reuse the script for other projects, right? In the
future.
Yeah.
The first picture, with a color rectangle, I reused in next project, yeah.
Mm-hmm. Perfect.
Just predefine the Excel attributes, and it's create. And at the end of the video, we can see I put the vertical dimension for the column and the slab measuring, and I create section views, EBC, and I put into this view the dimensions, and after that the section marks. Okay. Our design task was to design a steel flagpole from the permit design phase to construction design phase. But this was not our first flagpole design, so it made sense to automate this process. Shell model was created in Grasshopper for structural calculations, and this was used to generate the Tekla model. The parameter variables include such as diameter, length, the number, and the position of splices. Considering this, the structure can be fully parameterized. Yeah. But the interesting aspect of the model is that I place the welds and bolts and holes in the base plate and the connection plate using C# script editor in Grasshopper. I have used and continue to use these nodes in multiple projects and improving them. The images show the input data that needs to be provided for them. Yeah, in a weld nodes, yeah, you can see, yeah, the input data main and secondary part. We can set up the weld type like workshop or site. We can add the weld size, contour, finish above sorry, so yeah, above the line, for example. Yeah.
So you don't have to wait until Sebastian will finish his component for the welds. You have created your own, and you just creating the welds through C#.
Yeah, I try to create nodes, yeah, for welding. Yeah.
And I really like this panel that is showing the weld was successfully modified in the model. I really like also this method to showing like visually, like that something was inserted, that something was changed. It's really great way to work, and like I can imagine you can create this for several things if you would like to be sure that you have modified or inserted or deleted something. So yeah, cool. Let's go to next slide.
Okay. Yeah. Sorry. Yeah, this is a bolts node, and yeah,
it's much bigger.
yeah, it's bigger. Yeah, but lots of input data for create the bolts. Yeah. And yeah, we can set slotted hole or yeah, workshop site or the standard name. Yeah, and yes, I have a Python and C# code in this workflow. Yeah, with Python code count the tolerance and the hole. Yeah. And also I have a check panel with a green field. If it doesn't work, yeah, I get a red message. Yeah. Okay. The next video, we can see how to modify the Tekla standard grid and how to create the views, plan and section views, open one of the views, and then model steel rod and their basement base plate connection. Like put a hole, put anchor, washer, nut, and weld. Yeah. The last project was a precast building. After the opening of the project, I completed the following task in the Tekla model: setting up the grid based on the provided data, creating phases, and modeling the pies. I believe this task would take longer to complete using manual methods. As for example, we all know phases are added one by one in the phase manager in Tekla. But however, with a good script, all of this can be done faster. Yeah.
So what we are seeing at the screen right now?
This is the input data the input for creating the grid was provided by a DVG file, which contained two layers, curves and text. And the next picture, we can see parts of the code. First, reading grid data from Rhino. Next, determining grid X, Y coordinates, and modify grid, add grid line, and then also modify grid line. Yeah. These industrial buildings typically have a square or rectangular footprint with the intersecting grid lines forming 90-degree angles. The horizontal and the vertical grid lines can be separate. For example, they can be grouped into lines parallel to the x-axis and lines parallel to the y-axis. The intersections of these lines and their coordinate values can be determined, as well the distance between the intersection points. Moreover, the points can also be arranged in order. Yeah. To create the Tekla grid, we need to provide the x, y, and z coordinates of the grid points. In the panel named set, we can see the x coordinates values. However, these values cannot yet be used directly for the Tekla grid. The difference between two coordinate values must be calculated, as you can see in a difference panel. Yeah. And then formatted appropriately to serve as input data for the Tekla grid, as you can see in a formatted data panel and inserted list panel.
I understand.
Yeah. Yeah. Okay. By providing inputs such label name, coordinates, or like magnetic or logged, or change color or font. Yeah, you can do it with a script. And yeah, with script, I can modify the grid. Moreover, it is also possible to add a new green line and modify them in Tekla. And this is an example of output grid in Tekla.
Defining it manually will take some time.
Yeah. If you have input data in a DVG file, yeah, you measure every intersection point for the distance, and after that, you type in
manually. Yeah, you can use.
Yeah.
There's some components in Tekla Live as well, right? To create a grids, but maybe not. But maybe it will be faster with your components to modify them.
Yeah. But I love to modify standard setting in Tekla, like standard grid, EBC and 126. And yeah, the next video we can see it.
Yeah. Let's show us.
Yeah. The Tekla plugin does not include the node for creating phases. For this, I created a Python code where the phase name, phase number, and comment need to provide it as input data. In this picture, you can see how I generated the phase name and yeah, phase name and phase comment. Yeah.
And as I said, Andreas is going to share with us this particular script. So looking forward to this one.
Yeah. And after successfully generating the phases, the information shown in the picture is provided as output. Yeah. And the phase info from Tekla, any object phase input data. Yeah. And this is the output in Tekla. Yeah. As input data, I received the pile positions and their diameters categorized by color. Additionally, the DVG layer name contained the pile diameter, pile mark, pile length, and the z coordinate of the lower plane of the pile cap. Yeah. Yeah. And the next video, we can see how to modify the Tekla standard grid, create yeah, and this is the output of piles. And this is a short video. Yeah, modify grid, change color and grid label text size, and after created phases and put the piles into Tekla, and then I check some attributes in one of the piles, name, diameter, or UD, and the pile phase number.
Amazing! This is really amazing. I really love it. Was it the last example that you would like to show us today, or you have something more to show us?
It was the last. I have 2 slides with a short summary because we arrived at the end of the presentation. A short summary from me in the field of civil and structural engineering design. Digital tools and programming are becoming important. The goal of my presentation has been to demonstrate how the integration of Grasshopper and Tekla structures can be effectively applied in the structural design through parametric modeling, algorithmic-based solutions, and automated processes. We can unlock new possibilities and solutions. And thank you for your listening. Chris, thank you for your invitation. And if anyone has any questions, feel free to contact with me. I would be happy to answer.
Perfect. Amazing. Like I'm really happy. Like you can share your screen and go to the end of your presentation. I'm really happy to see my students' work as you are presenting. When we discussed 3 years ago, you've been starting with Grasshopper, and now you are really into programming. You know how to write Python, C#, and you are creating amazing things. So it's really also my heart is also warm and happy to see how my students are developing. So this is also give me power and like motivation to work with the trainings. And I'm not working that much with projects right now, but when I'm seeing my students working with this amazing thing, I'm really happy. So that is really great, and thank you for presentation. We have some free questions, so we can maybe try to answer. If not, so if you also have some detailed questions, so for sure you can contact Andreas through Discord. Right, Andreas? Andreas also tried to help, and he's also active on Discord and answering questions. So he's also there. I will also show one more thing because before we are going to present questions. So what is happening on the Grasshopper in Tekla training in February? In the next month, my good friend who I've been working 8 years in Sweco in my previous company. Eystein Ulvestad, he's going to be our guest only for Grasshopper in Tekla training students. So Eystein is going to talk about model-based project, how he's doing his work. He been speaker in the biggest conferences in the world, and he has amazing experience from Norway and Australia about implementation of model-based project. So it will be. I'm really looking forward to this presentation. What is coming more? I'm going to add new case studies and new updates for new components, so new lessons will be updated. So that was all for me. I have some questions. So let me see. Andreas, do you see maybe my screen with Grasshopper?
Yeah.
We have one question from Vanessa. She asked, how can you automate the destination and source file location for the data output and data input component? So she's asking, is there any way to automate defining the destination as the folder and the same for the input to not change it every time when you are opening your file, so you have to update it, right? Andreas, have you found any way to automate that one?
I recommend these two nodes because I in the beginning I have a huge spaghetti monster, and
now you can divide it to smaller parts. But have you found any ways to automate that you can instead of clicking it manually every time to destination, that you can write some Python and C# access, for example, through C# and change this destination?
I use only the Grasshopper nodes. No any Python or C# because I don't examine this workflow.
I'm sorry, Vanessa, but I don't have any recommendation, any experience with that. For sure, it's supposed to be possible to automate it anyway, anyhow, because I'm feeling you like changing it every time, like manually every time when you are opening scripts. It could be fine. I will try to look for it, and maybe I will try to find out the solution how to get this automated. The panel, you showed the panel, Andreas, that was showing the changing the color and showing it was the good or bad result. And Martin is asking how this check panel that you created is working. This is a cluster after the panel is changing the panel color based on the message, or is it meta hopper, or what are you using?
Meta hopper plugin with Python and C# code.
Yeah, I also in similar way, Martin. Maybe if you are familiar with my other trainings as a Grasshopper fundamentals or Grasshopper in Python in Grasshopper or C# in Grasshopper, I also used MetaHopper, and you can just go here to attributes and set panel properties. So, for example, here you can change the color of the panel. So there's a few ways to select a panel. One of the way is to get selected objects, connected objects, or get selected. So, for example, you can connect this panel, and you will see that this is a panel connected, or maybe you can also just select us in this component. I will just show the names. So you can see get selected component. So in the param object, so you can see that you can connect the panel. So you can go to panel, and here you're supposed to change the color. So let's check it, if you can just change it. Color, yeah, voila. So now you can change the color. So you can also automate that. So if you make an answer, so if there will be results that you meet conditions, so it will this action will happen. So I hope, Martin, that we answered your questions. Vanessa, she come back to this input and data. I wish the data output and data input worked like that read file component, so I could concatenate the file directory. Yeah, it could be really cool, like this future, like for example, just connecting the text, let's say, and with the direct dictionary. So it will be really cool. Maybe we will try to find out some solution for that one. And the last question for today, it's already late. Alvaro, I don't know, Andreas, if you see question. Can you see the question?
Yes, I see.
Yeah, Alvaro asked, was the layout used in the drawing created with Grasshopper, or it is a regular TPL file made in the Tekla environment? So was there any layouts used in these drawings that you showed?
I created a workflow with automation, automated which layout want to use in the drawing. So in the Excel file, I fill a cell with layout, which layout I want to use, and the drawing link, I input data. The Excel includes the input data for the layout.
Yeah. So yes, Alvaro, the layout was used there. Okay. Thank you very much for the presentation. Some people with us, Jan was with us, was Alvaro, was Vanessa, Leonardo. Nice to see all of you. And yeah, Andreas, thank you very much for the great presentation. Thank you for being active on Discord forum and for helping other students. As you know, when you are helping others, you are also learning. So I really admire how much you learned in the last 3 years. So I cannot imagine what are you going to do in next 3 years. So let's stay connected, and let's see all of us on Discord and learning platform. Bye bye.
Bye bye. Ciao.